Welcome students. Welcome to St. Joseph's open web-based learning platform. So we learn for a soulful and enriching e-learning experience. Welcome to Department of Mathematics. Our topic name is Differential Equations. Instructor for this chapter B. Bharati, MSc Mathematics, Assistant Professor, Department of Mathematics, St. Joseph's College for Women, Autonomous, Vishakhapatnam. Learning outcomes. By the end of this chapter, students will able to learn to solve exact differential equations using the method of integrating factors. Able to understand the concept of exact differential equations with other fundamental concepts in calculus and differential equations such as partial derivatives. Third point, students learn to understand the behavior and characteristics of the solutions. Let's see the content of this topic. Introduction, definition of exact differential equation, working rule to solve exact differential equation, related examples. Our topic name is exact differential equations. Today I would like to give an introduction about exact differential equations. What is exact differential equation? Is a type of differential equation that can be solved directly without the use of any of the special techniques in the subject. It is an equation that contains one or more terms involving the derivative of one variable with respect to the other variable. The definition of exact differential equations. Definition is a differential equation of the type m of x comma y into dx plus n of x comma y into dy is equals to 0 can be said as an exact differential equation if there exists a function of two variables f of x comma y having continuous partial derivatives such that f at x of x comma y is equals to m of x comma y and f at y of x comma y is equals to capital N of x comma y. Whereas here f at x and f at y are two partial order derivative with respect to x and y. It means an exact differential equation has of the form m of x comma y into dx plus n of x comma y into dy is equals to 0 where m and n are functions of x and y. It is called exact if there exists a function f of x comma y with continuous partial derivatives such that f at x of x comma y is equals to m of x comma y and f at y of x comma y is equals to n of x comma y. In this slide, let us see working rule to solve an exact differential equation. Step 1. Compare the given equation with m dx plus n dy is equals to 0 and find out dou m by dou y and dou n by dou x value individually. If dou m by dou x is equals to dou n by dou y, then the given equation is exact. Coming to the step 2, after given equation we conclude is an exact, integrate m with respect to x, treating y as a constant. Move on to the next step. In step 3, integrate n with respect to y, treating x as a constant and contains only those terms not containing x. Coming to step 4, solution of an exact differential equation is integral m into dx plus integral n into dy is equals to c. Let us see some examples related to exact differential equation. Example 1. Question is, find the solution of the differential equation y into e to the power of x into dx plus 2y plus e to the power of x whole into dy is equals to 0. Coming to the solution, first write down given equation as it is, that is y into e to the power of x into dx plus 2y plus e to the power of x into dy is equals to 0. If you compare given equation to the standard form of exact differential equation, here m is nothing but y into e to the power of x and n of x comma y is nothing but 2y plus e to the power of x. Next we need to find out partial derivative of m with respect to y as well as partial derivative of n with respect to x. Coming to the first partial derivative of m with respect to y. With respect to y, here y into e to the power of x. Here y becomes 1 because we are doing derivative with respect to y. Left over part is e power of x. Coming to the n of x comma y is equals to 2y plus e to the power of x. Take partial derivative on both the sides with respect to x. Dou n by dou x is equals to, in the first value 2y. Since there is no x term, so this whole thing becomes 0. Derivative is applicable for e power of x only. So derivative of e power of x is again e power of x. If you observe these two values, both dou m by dou y and dou n by dou x values are equal. So we conclude dou m by dou y is equals to dou n by dou x. Whenever we got both the values are equal to each other, then we can directly conclude given differential equation is an exact. After conclude given differential equation is exact, next step we need to find general solution for the exact differential equation. For that we have a formula integral n into dx plus integral terms not containing x means integral n into dy. Here n we are choosing terms not containing x is equals to c. That implies integral, we already differentiate what is m terms and n terms. Write down y into e to the power of x plus, before going to write n terms here, make sure that those terms not containing x. So integral dy into 2y into dy is equals to 0. So after doing integrating part, y into e to the power of x plus 2 into y square by 2, here 2 get cancelled, left over part is y square is equals to c. This is the required solution for the given differential equation. Let us solve example 2. Solve the differential equation 12x plus 5y minus 9 into dx plus 5x minus 2y minus 4 whole into dy is equals to 0. First write down given equation as it is, that is 12x plus 5y minus 9 whole into dx plus 5x minus 2y minus 4 whole into dy is equals to 0. Move on to the next line, compare it with m into dx plus n into dy is equals to 0. After comparing given equation to this standard form, we directly say m value is 12x plus 5y minus 9 and n is nothing but 5x minus 2y minus 4. Next step what we are going to do means take partial derivative of m with respect to y on both the sides. Left side part becomes dou m by dou y, which is equals to 12 into x. Since y terms are no, y involvement is not there, no, so derivative part is 0 plus 5y with respect to, we are doing partial derivative with respect to y, no, so it becomes 1 into 5, again we got 5 minus 9, since there are no y terms, so directly we got 0. Next, here also doing partial derivative with respect to x on both the sides, so left side part becomes dou n by dou x is equals to 5 into, here x involvement will be there, so 5x means we got 5 minus 2y, since there is no x involvement, so this thing becomes 0 minus constant, again derivative of constant is 0. Finally we got dou n by dou x value is equals to 5. After comparing dou m by dou y and dou n by dou x, we got same value. Since we conclude dou m by dou y is equals to dou n by dou x. Therefore, given differential equation is exact. In the previous slide, we conclude given differential equation is an exact. Now, whereas in this slide, we are going to solve the solution for the given differential equation. Formula is integral m into dx plus integral n into dy. But make sure that it's not containing x terms is equals to c. Write down m and n values here. So first write down integral. Instead of m into dx, write down m value 12x plus 5y minus 9 into dx plus integral. Before going to write n value, make sure that not containing x terms. So minus 2y minus 4 into dy is equals to c. Move on to the next line. If you apply integral to each and every term, 12. Integral applicable only for x into dx. Integral x into dx becomes x square by 2 plus integral 5 into y. 5 into y treated as a constant, so take outside. Integral 1 into dx becomes x. So that is how we got 5 into xy minus 9 is constant, so take outside 9. Integral 1 into dx is x. So after applying integral to each and every term, we got 12 into x square by 2 plus 5xy minus 9x. Coming to the second integral part. Minus plus into minus minus, since 2 is constant, take outside. Integral y into dy means y square by 2 plus integral 4 into dy, again 4 take outside, and integral 1 into dy is y is equals to c. Move on to the next line. Here 2 ones 2 6. Similarly here 2 get cancelled. Left over thing is 6x square plus 5xy minus 9x. Apply negative term to this bracket. Minus into y square. Here 2 anyhow get cancelled, no? Plus into minus minus y square. Minus into plus minus 4y is equals to c. Let us solve example 3. Given question is solve the differential equation 1 plus e to the power of x by y into dx plus e to the power of x by y into 1 minus x by y into dy is equals to 0. Solution. First write down given equation. Given equation, that is 1 plus e to the power of x by y whole into dx plus e to the power of x by y of 1 minus x by y whole into dy is equals to 0. Next line, we are going to compare given equation with the standard form. That is m into dx plus n into dy is equals to 0. After comparing given equation to the standard form, we clearly see the m and n values. So here m is nothing but 1 plus e to the power of x by y, and we got n is e to the power of x by y into 1 minus x by y. Next line, we have to do partial derivative of m with respect to y. So dou m by dou y is equals to, we have to do partial derivative with m with respect to y, no? So here 1 is constant, so this value becomes 0. So this partial derivative applicable for the second term, that is e to the power of x by y. So e to the power of x, we are doing partial derivative for the e to the power of x by y, no? So it will come as it is. And we have to do derivative for the inner derivative we are going to take. That is minus x by y square. X will be same again. 1 by y derivative is minus 1 by y square. Coming to the n function, before going to see the n function derivative, here we are going to apply derivative of uv. u into v dash plus v into u dash. Whereas here we are going to take partial derivative of n with respect to x. So the left side part becomes dou n by dou x is equals to, okay, in this n function, e to the power of x by y we treated as u, and 1 minus x by y we treated as a v. Now we are going to apply uv formula here. U means e to the power of x by y into v dash. What is v dash here? 1 minus x by y. We have to take derivative for this v. So 1 becomes 0. And if you do derivative for minus x by y means with respect to x, no. So this becomes 1 minus 1 by y plus v into u dash. First write down v term, that is 1 minus x by y into u dash. What is u here? E to the power of x by y. After taking derivative of e to the power of x by y, again we get e to the power of x by y, and inner derivative is 1 by y. Continuation of the previous slide. So in the previous slide we got dou m by dou y and dou n by dou x value. Now write down same. Dou m by dou y is equals to e to the power of x by y into minus x by y square, and dou n by dou x we got minus e to the power of x by y plus e to the power of x by y minus x by y square into e to the power of x by y. Next line, dou m by dou y is equals to e to the power of x by y into minus x by y square. Write down this value as it is. Coming to the n function, dou n by dou x is equals to, here we written only minus x by y square into e to the power of x by y. What happened, these two terms means these two are get cancelled. If you look into m and n function, both the functions have a same value, that is e to the power of x by y into minus x by y square. Here also we got minus x by y square into e to the power of x by y. Both the functions have same value, no? Therefore we conclude dou m by dou y is equals to dou n by dou x. Given differential equation is an exact equation. Hence the general solution is integral m into dx plus integral n into dy is equals to c. In the previous slide, we are started to find general solution for the given differential equation. Formula is integral m into dx plus integral n into dy is equals to 0. So write down integral, what is m? We got 1 plus e to the power of x by y into dx plus integral n into dy. Make sure that it is not containing x terms. So excluded x terms, we have to write only y terms, no? So integral, there are no x term, there are no y terms here. So simply integral 1 into dy is equals to c. Move on to the next line. Apply integral individually. So separate this integral. Integral 1 into dx plus integral e to the power of x by y into dx plus integral 1 into dy is equals to c. Integral 1 into dx value is x plus integral e to the power of x by y value is e to the power of x by y by 1 by y plus integral 1 into dy value is y is equals to c. Move on to the next line, x plus, bring this y to the numerator part, y into e to the power of x by y plus y is equals to c. Hence, the required solution of the given differential equation is x plus y into e to the power of x by y plus y is equals to c. Thank you for sparing your valuable time.